There's a moment in every technology company's automotive journey where they stop hedging and start swinging. For some brands, that moment comes gradually through a series of incrementally bolder product announcements. For Xiaomi, it came at Mobile World Congress 2026 in Barcelona in the form of a virtual hypercar with a projected output of over 1,900 horsepower, Venturi tunnels large enough to walk through, and wheels that appear to stand still while the car is moving. The Vision Gran Turismo concept is the most unambiguous statement of automotive ambition that any Chinese technology company has ever made, and the fact that it exists primarily as pixels rather than metal doesn't diminish that ambition in the slightest, it amplifies it. Understanding why this matters requires a moment on what the Vision Gran Turismo program actually represents. Polyphony Digital's collaboration with automotive brands isn't simply a marketing exercise dressed up in racing game clothing. The program grants manufacturers something genuinely valuable and genuinely rare: creative freedom without regulatory consequence. No crash tests, no homologation requirements, no engineers explaining why the downforce targets and the ride comfort targets are incompatible with each other. Just a brief that says, show us what you'd build if the only constraints were imagination and physics. The brands that take that brief seriously produce concepts that reveal genuine design philosophy and genuine engineering ambition. The brands that treat it as a promotional tool produce something forgettable. Xiaomi, making their debut as the first Chinese marque to enter the program, have very clearly taken it seriously. The technological foundation of the Vision GT is Xiaomi's advanced 900-volt silicon carbide electrical architecture, the same high-voltage platform direction that has been establishing itself as the benchmark for serious performance EV applications. Silicon carbide semiconductors handle power conversion more efficiently than conventional silicon components, which means less energy lost as heat, faster charging capability, and better power delivery across a broader range of operating conditions. On a vehicle projecting over 1,900 horsepower from its electric powertrain, those efficiency advantages matter in ways that go beyond headline figures. They affect thermal management, sustained performance under load, and the reliability of power delivery at the extreme end of the output envelope. The choice of 900-volt architecture for a concept of this type isn't decorative. It reflects genuine thinking about what a performance EV platform needs to function at this level. The power figure itself deserves a moment, because 1,900 horsepower is a number that restructures the conversation about what's possible. The most powerful production hypercars currently available, the Bugatti Tourbillon, the Rimac Nevera, the Koenigsegg Jesko Absolute, operate in the 1,000 to 1,600 horsepower range. Projecting beyond 1,900 from an electric powertrain places the Vision GT in territory that doesn't yet have production precedent, in a vehicle that weighs significantly less than most of those machines given its racing car construction philosophy. The instantaneous torque delivery that electric propulsion provides compounds those figures in a way that combustion output numbers don't fully communicate. The power is available immediately and completely, without the sequential build through a rev range that characterizes internal combustion performance. What that means in practice is acceleration that genuinely doesn't have a current real-world equivalent. The aerodynamic philosophy is where the Vision GT's design reveals the depth of thinking behind it, and it's worth spending time here because this isn't styling that happens to reference motorsport, it's an aerodynamic architecture that has been allowed to determine styling. Xiaomi's head of automotive design, Li Tianwan, describes a drag coefficient of 0.29, which is a figure that requires context to appreciate. An efficiency-focused EV can achieve lower drag than that, but those vehicles are optimized to minimize resistance without generating meaningful downforce. The Vision GT's 0.29 reflects the balance point between acceptable drag and the substantial downforce generation that the underfloor-underbody architecture creates, the same fundamental approach used by the Aston Martin Valkyrie, the Red Bull RB17, and the most extreme closed-wheel racing machinery. Getting to 0.29 while running the Venturi tunnel configuration visible in the concept's underbody images represents a genuinely sophisticated aerodynamic result. Those Venturi tunnels are the defining feature of the underbody and the primary source of the downforce the concept generates. The principle is well established in racing car design: channel air under the vehicle, accelerated through a narrowing section, and the resulting low pressure zone beneath the chassis pulls the car to the road with forces that increase as speed rises. The faster you go, the harder the car is pushed down, and unlike wing-generated downforce, ground effect downforce doesn't increase drag at the same rate. The concept's dramatic tail section works in concert with the underfloor, ejecting the accelerated air in a way that maximizes the pressure differential and therefore the downforce load. No official figures have been released, but the architecture implies cornering forces that would be physically demanding on a human driver, even in a simulated environment. The front end is handled with a motorsport specification carbon fiber splitter that manages the initial airflow while contributing structural rigidity, the first aerodynamic surface that air encounters on the vehicle, and consequently one of the most important for establishing the pressure distribution that the rest of the underbody relies on. Slim LED headlamps integrate into the bodywork with the kind of aerodynamic cleanliness that suggests the lighting team and the aerodynamics team were in the same room rather than working sequentially, which is exactly how it needs to work on a vehicle where every surface has an aerodynamic consequence. The side profile is taut and functional, with carefully defined channels guiding air toward the rear extraction system in a way that maintains the visual coherence of the overall design while serving a specific airflow management purpose.
The rear fascia is where the drama concentrates most visibly. Beyond the Venturi tunnel exits, which are large enough and prominent enough to dominate the rear visual impression, a continuous LED taillight spans the full width of the car, framing the aerodynamic voids with a luminous signature that is unmistakably Xiaomi in character. This isn't an accident or an aesthetic choice made independently of the engineering. Xiaomi makes display technology. Their consumer electronics heritage is built on screens, on illuminated interfaces, on the experience of light as information and identity simultaneously. Translating that expertise into a continuous wraparound taillight on a hypercar concept is the kind of brand-coherent decision that reveals genuine creative thinking rather than a design team working without a brief. The interplay between the illuminated surface and the sculpted carbon fiber forms around it creates a visual statement that is immediately distinctive and would be recognizable at a distance. The wheels deserve specific attention because they're one of the most technically interesting details on the entire concept. Turbine-style rims with floating covers create the optical illusion of stationary wheels on a moving vehicle, an effect that has appeared on concept cars before, but rarely with this level of commitment to the execution. Beyond the visual intrigue, aero disc covers of this type serve a genuine function by reducing turbulent airflow around the wheel arches and improving the aerodynamic efficiency of the undercarriage. The carbon ceramic braking systems beneath them are the appropriate hardware for a vehicle generating these levels of speed and downforce. Conventional iron rotors wouldn't survive the thermal demands of repeated hard braking from very high speeds, and carbon ceramics' resistance to brake fade under sustained load is fundamental to the concept's credibility as a racing machine rather than just a visual exercise. Inside, the cockpit philosophy is pure motorsport. Occupants sit low within a carbon fiber monocoque that prioritizes structural rigidity and minimal mass over the kind of comfort considerations that have no place in a vehicle of this type. The cabin is compact and driver-focused in a way that communicates performance intent before you've looked at a single specification. A panoramic head-up display stretches across the driver's full field of vision, replacing conventional instrumentation with a seamless augmented reality interface that delivers real-time data without requiring the driver to look away from the road ahead. The implementation echoes advanced HUD systems seen in vehicles like the BMW i3, but pushed considerably further in terms of coverage and integration, which is consistent with Xiaomi's ability to develop sophisticated display technology at scale. The steering wheel is the interior detail that most clearly demonstrates Xiaomi's consumer electronics heritage translated into automotive form. 5 large circular displays are embedded directly within the wheel structure, providing telemetry, performance metrics, and system controls with immediate visual access. Among the selectable modes is a dedicated drift function, which positions the concept firmly within the playful, high-performance character that Gran Turismo's virtual environment enables and rewards. Multiple integrated digital interfaces within a single steering wheel input device is exactly the kind of human-machine interaction solution that a company thinking about vehicles from a software and hardware convergence perspective would arrive at. It's not a solution that comes from traditional automotive design thinking. Whether any of this translates into a production vehicle is the question that surrounds every Vision Gran Turismo entry, and the honest answer is that the most extreme elements almost certainly won't survive the journey from virtual concept to road-legal reality unchanged. The regulatory and engineering challenges involved in producing a ground-effect hypercar with 1,900 horsepower for public road use are formidable enough that even manufacturers with decades of relevant experience approach them carefully. But production feasibility isn't really the point of this exercise. The point is ambition, direction, and the projection of identity at the highest possible level. On all 3 counts, Xiaomi's Vision GT delivers completely. It tells you where the company wants to go, how seriously they're taking the automotive space, and what kind of thinking they're bringing to a conversation that traditional manufacturers have dominated for over a century. That's a meaningful statement from a smartphone company that started selling cars less than 2 years ago.